Yeah, thank you very much, Joanna, and what a great presentation, Bastian. What I wanted to cover today is actually, and I was told it's a tough 7 minutes line, so I'm going to make sure that I'll keep this, to actually cover a couple of examples from the World Food Program of specific artificial intelligence in action, like what we have there. And so just as a little bit of background, so like my name is Brian Kovacs, the head of the World Food Program's Innovation Accelerator. So if you don't know who we are, so we are the World Food Program's Innovation Accelerator globally. So we have 5 functions that look from like frontier innovations, identifying innovations, running our bootcamp sprint programs up towards scale-up enablement, with the ultimate goal to actually have impact at scale. So we have, out of the last 5 years that we're operating globally, already 11 projects that go into multiple countries and impact the lives of more than 100,000 people. And most recently, we also actually we've really focused on sharing knowledge and some of the lessons learned. So we've had several work that we've done for also like accelerator programs for the Bill and Melinda Gates Foundation, together with UNICEF and WHO, Humanitarian Grant Challenge, and the UNDSC. That's a collaboration of UNHCR and WFP, running like these boot camps, sprint support, but also scaling support. And all of what we're doing is already virtual, and like we're focusing on innovations. And this is where I think it's also a good addition to what Bastian was talking about. There's a technical aspect to innovation, but there's also an aspect of like the methods, the tools, the teams that you actually have to think about. And the first topic that I want to talk about that's relevant, it's still an early stage exploration. It's called Sky, and it uses artificial intelligence to do damage assessment in emergencies. And the basic idea here is like, how would an AI-enabled WFP look like? So now imagine you are in a natural disaster situation where a typhoon, a hurricane, landslides have occurred. What if we could use artificial intelligence to analyze images provided by satellites to the humanitarian organizations, so they can provide what is required to the right people at the right time where it's most needed. And this is the basic idea behind using AI in this scenario. What oftentimes in the past, like, and there's obviously different UN organizations, NGOs also that do this on a day-to-day basis, and that's life-saving work, but it sometimes takes up to 3 weeks to really classify and assess the damage of buildings, destruction of villages, and so on, and that thereby giving an indication where are people in need. Now, what the goal of this AI tool here is, Sky, is to do this within 24 hours to actually help identify those prioritized areas. And now you might say, well, yeah, but why? Why is it so important? Well, some of you who are also active in emergency response, and this is where also is World Food Program, a lot of the activities that we're active in is like about saving lives in emergencies. There's a lot of decisions being taken in the first 24 hours, in the first 72 hours that are based on the best available data that you can possibly have. Now, if we have better data, would that not be better if we could possibly do that? And now this is where Sky comes in. So in the project, what we've been doing also with the kind support of a tech company to actually train these models. So we actually put together satellite images on the one hand and labeled data. So this is data that have been, is publicly available, that's already labeled from previous emergencies that looked into damage assessment, like assessing the buildings and also damage assessments. And we've been trying to say, okay, how can we bring these together and generalize models that we could deploy immediately in a emergency setting. Now, looking at some of the examples here, so we have been testing this in a couple of, like looking backwards in how good the model performs. So like in the Haiti earthquake, it was 83%, Mexico City earthquake, 71, Indonesia earthquake, 78%, and then in Syria, 75%. Now, 75% accuracy may not be ideal yet. So like there's definitely something that needs further improvement. However, the question is like, if you have the choice between like 75% accuracy within 24 hours, or maybe 95% accuracy, because even humans, when they're doing this kind of labeling, are not perfect, in 3 weeks' time. That's a trade-off that, as humanitarian aid workers, something that we can actually take into account. And this is really where the project where it's right now is, it's still on an experimental stage, where we're trying to see on further on the ground use cases, like on test cases, where can it be helpful, and what exactly, and like, can it be better generalizable? Because I think that's one of the questions that was asked in the Q&A before, is like, why do you need artificial intelligence? Well, if you train an AI algorithm on the Haiti earthquake, and it's great in forecasting the Haiti earthquake post factum, that's great. The problem is, though, you need to actually, in order to be useful, it has to be applicable wherever the next earthquake is. And I think this is where the model has to come in. Now, coming to the second example I want to mention, which is Hunger Map Live. And it's the World Food Programme's global hunger monitoring system that tracks and predicts hunger in near real time in over 90 countries. Now, you may know that for us, I mean, what we're doing already to assess the hunger in different areas, we might do like mobile phone calls, SMS-based surveys, use a multitude of other like field-based monitoring data to actually do that already. But there's also other things that we may want to consider, like, what about like hazards or weather events, undernourishment data, rainfall, vegetation data. And we need to bring all of that together to identify where are the most people in need and how many are actually in need in these areas. And so this was behind Hunger Map Live. What it does, and I'll show this to you like just real quick. You can actually go on the site. It's hungermap.wfp.org. It's a near real-time map of like that shows you the undernourishment of populations in over 90 countries, and most recently also including COVID-19 statistics. And so what's new about this? Like, it's a map, you might ask. Well, what's new about it, it also has a predictive model where we don't have enough data, because we, like, for instance, maybe to not burden the population, you don't do daily food security surveys. At the same time, you may not have access to a food security service in all regions where we active, not in 90 countries worldwide. So what the predictive model does, it actually uses the data of, like, let's say, vegetation, rainfall patterns, nightlight, so things that we've heard before, to use predictive modeling of food security at the near real time. And the results of that are important for us as people who have to take decisions, but similarly for decision makers who are talking about, like, how is the situation looking like. And I give an example. So I just took this, it's from today, is an example from Yemen, where you see the COVID-19 stats, but you also see the number of hungry people, for instance, in this case, that are modeled, they're actually like based on the model, and also, for instance, news that are being tracked. Like, if there's funding income by the US government or by the World Bank that actually is being pledged for a particular emergency. So you may see these things already by certain funding inflow, thereby food security trends in near real time, whereas otherwise it may take a couple of days. So with that, I'll open it for questions, and thank you very much for the attention. Like, please do reach out if you have other questions. We're also working on other projects on artificial intelligence, blockchain, and other things. Thank you very much.